Yeah. Yeah. Okay. You guys should know by now, solving equations, we got to do inverse operations to get the variable by itself. So like if I said this, you don't have to write these down. What would you do to get x by itself? Divide both sides by 6. And x is equal to negative 18 by 6, which is negative 3. What would you do to get x by itself? Subtract 7 from both sides. You get x equals negative 1 subtract 7, which is negative 8. How about this one? Add 10 to both sides. And therefore, x is equal to negative 6 plus 10, which is 4. How about this one? Everybody see that? Multiply by 4. So we're going to multiply, and I'm going to show it to you like this. We're going to multiply, so we put parentheses around the term, and then we're going to times it by 4. And we have to do the other side times 4. Well, notice that times 4 and divide 4, they cancel each other out. So you're just left with x. And that will equal 4 times negative 3, which is negative 12. Okay? This last one is something we call a fractional, or another name for fractional in math, and we've used it already this year, is rational. Okay? So we're going to look at solving some rational equations, which we just solved one. The last example was a very simple one. These are a little bit more complicated because notice there's more than one fraction. Okay? When you see a fraction equation, the first thing you want to do is get rid of the fractions. Okay? So I want to clear the fractions. And remember, fractions is just the same as division. So how do I get rid of division? I multiply. By multiplying, well, here, this is a little weird this time because there's more than one denominator. What would I multiply to get rid of this fraction? 2. What would I multiply to get rid of this fraction? Okay, so, but it has to be the same number, right? To get rid of the fraction? So what could I multiply by to get rid of 2 and 10 at the same time? That's sort of the trickiest part of these. What could I multiply by so that it clears all the fractions out, no matter what the denominator is? What I can do is I can multiply by the lowest common denominator of the fractions. And I'll show you how that works when we do that. So I'm just going to rewrite this question. 3a over 2 minus 1 equals a over 10. What's the lowest common denominator of 2 and 10? In other words, the smallest number that 2 and 10 go into. That's the greatest common factor. 10, right? 10 is the smallest number that both of those go into. So what I'm going to do is I'm going to, and remember, we have to multiply everything by 10. Everything. Now watch what happens when we do the fractions. Well, remember, 10 is the same as 10 over 1. This is why I was showing you guys how to reduce fractions before multiplying at the beginning of the year. What can I reduce the 10 and 2 down to?
5 and 1.
5 and 1. So what am I left with? 5 times 3a over 1 times 1. Well, if it's 1 on the bottom, I don't have to write it, do I? What's 5 times 3a?
15.
Notice, fraction's gone. This next one, I don't have to worry about a fraction. I just have to do minus 10 times 1, which is 10. But this one, remember, 10 is the same as 10 over 1. What can I reduce these to? 10 and 10. What can I divide those, each of those by? 10. So I get 1 and 1. So 1 times a is a over 1 times 1, which is 1, and I don't have to write over 1. So it's just a. Notice the fractions are gone, and now it looks like a question we did yesterday, where we've got variables on both sides. Remember, when we have variables on both sides, we've got to bring them over to one side, right? So, and usually we take the one on the right and bring it over here. How do I get rid of a? Subtract a, which means I have to subtract the 15a by a. So I'm left with 15a minus minus 1a, which is 14a. There's still a minus 10 on the side, on the left side. But what's on the right now? 0. There's nothing there. And what represents nothing? 0. Add 10 to both sides. And that would be 14a is equal to 10. And then divide both sides by 14. And I get a is equal to 10 over 14. Well, that can't divide cleanly. Leave it as a fraction, but make sure it's reduced. 2, 5 over 7. So this one involves a little bit more, the fraction equations. But you really have to get a good handle on these, okay, because we are going to work with a lot of fraction equations in grade 10, 11, and 12. So what we want to do is try another one. Again, as soon as you see fractions, get rid of them. What would I multiply this equation by? 15, the lowest common denominator. So that means it's going to look like this. 15 times 2a over 3 equals 15 times 4a over 5 plus, even if it's not a fraction, you still got to multiply it by 15. Remember, 15 is the same as 15 over 1. Reduce. 15 and 3 can reduce down to 5 over 1. So what does this become? 10A. No more fraction. What can I reduce this to?
3 over 1.
3 over 1. So this whole thing becomes 12A plus 15 times 7. 105. So there you got it. Notice I have an equation that has fractions on both sides, or fractions, variables on both sides. So I want to take the 12A over here by getting rid of it here. How do I get rid of 12A? Subtract 12A, gone. Whatever you do to one side, you must do to the other. So you're left with negative 2A is equal to 105. And then I add 2, right? Add 2. Divide 2.
Yeah.
Divide 2. Say that you keep shaking your head. What should I divide by? Thank you. Remember, this is times negative 2. You got to divide by the exact same thing. That doesn't divide cleanly. So just leave your answer as a fraction, and it's already reduced. You can't reduce it. Okay? So those are fraction equations. So the only thing I want you to add for tomorrow, and we're done at 10:30 in this class today, because you guys get a little bit of a break before you go to advisory to listen to that presentation. Okay. Exercise 6.3, number 2, the fraction equations. You should now be able to do those fraction equations. Work on them now. Okay. I know half this class is like feeding themselves right now. What? You should have finished the rest. No, 6.2. 6. Oh, right, 6.3. Sorry. That's exercise 6.2, number 2. Sorry. Yes. Advisory.